Greetings, grade 12s, and welcome to Butu Academy, Lessons That Empower. So today we are on part 2 of our exam preparations series for the June examinations, particularly for the Gauteng matriculants, okay? So on part 2, we are looking at vertical projectile motions, as you can see. Remember, in the previous one, we looked at Newton's law. So now we are on the second part, which is vertical projectile motions, which will be one of the topics that is assessed on your paper 1 on the 15th of June. All right, now let's go straight into it. What is it that we can expect in this particular topic? Just like any topic or any other question, the first thing that you should expect are the definitions. This is one of those topics where there are very few definitions. Actually, there are 2 of them according to our exam guideline. So the only 2 definitions you need to focus on are projectile and free fall. Make sure you know both of them before going to the examination room, and make sure you can be able to distinguish between the 2 because they look quite similar. But the difference between the 2 of them is that the first one, which is a projectile, is actually an object. Okay, you'll see even in your exam guideline that a projectile is an object, whereas free fall is a motion, is a description of a motion, is a type of emotion. So in this case, you must not be confused between the 2. One of them is an object and the other one describes the motion. Those are the 2 definitions that you need to be sure of before going into the exam. Secondly, you should definitely expect calculations using equations of motion. This is a topic where there are 4 equations that we use very often, and those are the equations of motions. You should not worry yourself about memorizing them because they are always given to you. These are the 4 equations. Usually we label them as equation 1, equation 2, equation 3, and equation 4. All right, so you must be able to use them, and you must know when to use which equation, and that is exactly the tricky part about the calculations in this particular topic. You need to know how to choose the correct calculation for a specific question. Okay, so now in the next slide, what I want us to do is to look at the strategy on how to choose the most suitable equation for a calculation, because sometimes you are going to use a combination of equations to solve one problem. Sometimes you'll have to start with one equation and move to the next equation. But this is a strategy to show you what is it that you need to follow in order to choose the most suitable equation from the 4 of those equations. The strategy is, the first thing you need to check, what is it that you are given, or what is it that you know from the statement or from the graph, because sometimes your statement can come in a form of a graph, so you should be able to read the graph and get the information from the graph. Okay, so you need to note the things that have been given to you, and then move to what is it that is required of you, what is it that you need to calculate. And this is what I'm going to refer to as the unknown. So you need to know, okay, if the question says calculate the time taken, you know that you're calculating delta t. So, but you must also check what is it that they gave you, the examiner has given you in that particular problem. Thirdly, you need to choose one equation that has 3 of the given quantities. Okay, now I'm going to explain the number 3 just now. Okay, the thing is, with regards to the equations of motion, all of them have 4 quantities. All of them, all 4 of them have 4 quantities in one. If you can quickly go back and look at the equations of motions, you'll see that, look at equation 1, you'll see there's one variable or one quantity, there's another quantity, there's another quantity, there's another quantity. There are 4 of them. All of them are like that. There's 1, there's 2, there's the third one, there's the fourth one. There's the first one, there's the second one, the third one, and the fourth one. Of course, delta t in this case repeats itself. This is the same for equation 4, 1, 2, 3, 4. So with all the equations of motions, there are 4 quantities. Okay, so if you know 3, obviously if you know 3, you can calculate the fourth one. So when you are calculating, check and choose one equation that has where 3 of the known variables are in that particular equation that you have chosen, and then the 4th variable or the 4th quantity must be the one that you're trying to calculate, which we referred to earlier on as the unknown. All right, but there is an even easier way of remembering things. When you are using equation 1, equation 2, and equation 3, you don't need 3 variables. You only need 2. The third one is your gravitational acceleration, because that is always 9.8 meters per second squared, depending on which direction you chose as positive. Sometimes it can be negative or positive, depending on your choice of direction. Okay, so with regards to the first 3 equations, you need to know 2 variables, and then the third one will be your acceleration. Once you know those 3, you can calculate whatever it is that you need to calculate. Okay, so the most important thing is to avoid having more than one unknown in your equation. So you must choose an equation where the 3 variables or the 3 quantities that you are going to use are known, or you already know them. Either they are given, or you've already calculated one of them. So don't confuse yourself. Make sure that you know 3 of the quantities, and then you calculate the 4th one, because each equation has 4 quantities. If you have the 3, you can calculate the 4th one. That's how you choose the most suitable equation in equations of motions. It can be very tricky because there are 4 equations, and sometimes you don't know which equation can work here. Sometimes more than one equation can work, but to choose, always find the one that is easier for you and the one that is going to take you straight to the answer without taking too many steps. All right. Now, let's move to the characteristics of a projectile. Remember, this is a topic that is centered around an object which is moving under the influence of only one force, which is the force of gravity, and that is what we call a projectile. So now you need to understand the properties and the characteristics of a projectile. What happens to an object that is moving under this kind of a motion, which is referred to as free fall. Now we're going to start with an object which is launched from the ground, of course, because situations will vary depending on the question paper that you are working on. Sometimes an object will be launched from the ground all the way to the top and come back to the ground, or it doesn't come back, it comes back to a new height. Sometimes an object will be launched from a height above the ground or from a point above the ground. Okay, so those are the 2 scenarios that we're going to look at. The first one that we're going to be looking at is if, let us say, this is your ground. Okay, so if this is the ground, you launch an object from here at point A. Okay, let me just fix that. Let's assume this is point A. This is where the object starts moving. The object goes up and then it comes back to point, let's say that would be point B, and this would be point C. There are things you need to remember about projectiles, is that at point A, you are going to have the initial velocity of the object, or you can just call it the velocity at point A. And at point B, you're going to have another velocity. Let me just call it the velocity at point B. But what happens as the object goes up? Remember, gravitational acceleration is pulling it down. The gravitational acceleration is pulling it down, okay? While the object was launched with a velocity greater than 0, it will keep on going up, but its velocity will decrease because acceleration, or the force of gravity, is pulling it down. While that object is going up, it's being pulled down by the earth until it reaches a point where it pauses at the maximum height. Point B is therefore referred to as our maximum height. Okay, so you'll have our maximum height at point B. That shouldn't be there. Okay, now what happens at point B? At point B, the object will pause for a moment, which means that the velocity at point B will be 0. Okay, after reaching the maximum height, now the object will return back to the surface of the earth, which means the earth is pulling it down in the direction of the acceleration, the gravitational acceleration. Okay, so now the velocity will start increasing, because remember, on the left hand side, on this side, while it was going up, the velocity was decreasing until it reached a velocity of 0. Now the velocity will start from 0, and then it will increase until we reach point C. What happens at point C, will have another velocity C. This velocity at point C, depending on what you are calculating, you can refer to it as your final velocity if you choose a motion between point B and point C, for instance. Okay, that velocity is the same as this one in terms of magnitude. These two have the same magnitude, which means if you launch the object with a velocity of 10 meters per second, it will come back and hit the ground with a velocity of 10 meters per second in the opposite direction. Remember, here you would have launched it up at point A, you would have launched it up with a velocity of 10 meters per second upwards. When it comes back and it reaches the same level from where it was launched, it will reach that point where it was launched with the same velocity, but in the opposite direction. So the same magnitude in terms of the velocity. Now let's move to another type of a scenario. This is a scenario where we are throwing a projectile upwards, but we are not starting from the ground. Let's assume this is the ground, okay? But we are not going to be throwing this object from the ground. Let's say we are going to be throwing it from at the top of a building. If this is the building with the height h, the object is launched upwards, it goes up, and then it goes back to the ground. Now it's going to hit the ground, okay? I'm going to have 4 points now. So at this point A, where the object is starting, then we reach point B, which is the maximum height. Point C is the point where the object returns to the same height from which it was launched, but then it doesn't stop there. It continues moving all the way to point D. The other things you need to remember here is that the velocity, the magnitude of the velocity at point A is the same as the magnitude of the velocity as in point C. But remember again, the object will be launched, it will go up, it will reach the maximum height. At point B, we are going to have the velocity becoming 0, and then it will come back at point C, which will have the same magnitude of velocity as in point A. Then from point C, the object continues moving downwards and the velocity increases until we reach the maximum velocity, which will be the velocity with which the object hits the ground. All right. So every time we are doing calculations, the equations of motions are such that you need 2 points to do a calculation. You can either do a calculation based on point A to point B, where your initial velocity will be the velocity with which the object was launched from the building, and the final velocity will be 0 because that's when you reach the maximum height. Or you could choose point B and point C, but depending on what is it that you're calculating, you could be calculating something that requires you to consider the motion from B to C, where your initial velocity from B will now be 0, and then the final velocity which you use in your equation will be the velocity at C, which is the same in terms of magnitude, is the same as the velocity at point A. Or you could be considering the motion of the object from point C to point D, where we don't, unless it's given, here we wouldn't know what is the velocity at point D. Let's say you want to calculate the velocity at point D. You would know the initial velocity. This height of the building will be your delta y. Your delta y would be the same as the height of the building if you're starting from point C. That shouldn't be there yet, okay? So just make sure that you understand the characteristics of this particular motion. Now we move to the next one. In the next one, we are looking at an object which is, again, either it's still on top of a building, which is any point above the ground. It could be on top of a cliff or a bridge or anything, but it's still an object which is launched above the ground. But in this case, what is going to be happening is that, okay, this will be your ground, okay? Now, what happens in this one, it's an object that is either going to be dropped or thrown downwards. So in this case, remember the previous one, we're throwing it upwards. That's what was happening there, okay? Now we are dealing with a downwards motion, which is starting from the height above the ground. So now I'm going to, let me just change a color here. I want to use a different color. Now, this can be done in 2 different ways, because to drop something from a height above the ground and to throw something from a height above the ground are 2 different things. And even in terms of calculations, they differ. Let's start with when you drop something. When you drop something from a height above the ground, to drop means you are releasing it from rest. Sometimes the ways that we use in the examination, we say an object above the ground is released from rest. That is the same thing as dropping it. The initial velocity for this is equals to 0, okay? So if the object is being dropped or it's released from rest, its initial velocity is 0. It's different from when you are throwing it. So let's say here's motion number 1. It could be, let's label it as 1. It could be that I've moved a little bit further. It could be that you are dropping this object from the height above the ground, and then the object will go all the way to point B. Let's say this would be now point B. The velocity with which the object is starting its motion is 0 because it's being dropped or it's being released from rest. Now, the second type of motion that could happen from a height above the ground is motion number 2, where the object will still be starting from a height above the ground, but it is thrown or it is launched with a velocity greater than 0, and it goes all the way to that point. Let's call this point D and call that one point C over there. At point C, the velocity is not 0, okay? So at point C, we are going to say the velocity here is not 0, okay? The velocity there is not 0. Why? Because the object is thrown down. It is thrown down with a velocity that is non-zero. I don't want to say greater than 0 because if you chose negative as your the downwards motion as negative, we can't really say the negative is greater than 0. Mathematically, that would be incorrect. So we're going to say the velocity is non-zero there, but the speed is greater than 0 because speed is a scalar quantity, okay? So those are the two types of motions that could happen from the top of a building and you are launching an object, but you're launching it downwards. It's either you drop it or you throw it. If you drop it, its initial velocity will be 0. And if you throw it, its initial velocity will be non-zero. But remember, while the object is going down, the velocity will definitely increase. So this is a motion where we know for sure it's the only thing that will happen to the velocity is that it will increase. Either it starts at 0 and it increases all the way until it hits the ground, or it starts as a velocity greater than 0 and it increases until the object hits the ground. Those are some of the basic characteristics of projectiles. I wanted us to look at various types of projectiles that you are likely going to encounter in your examination. Okay. Now, the third type of situation that you are going to face or you might be facing in your examination is the reading and the drawing of graphs. And this is a very tricky one for many learners in various phases of physical sciences, whether in grade 10, grade 11, or grade 12. The reading of graphs is quite a challenge, or the drawing of graphs is quite a challenge. Now, I'm going to start with the velocity versus time graph. If you are given the velocity versus time graph, what you are going to see is a straight line graph. Okay, so velocity time graph is a straight line. Now, what you need to know is what is represented by what on the graph. The first thing is that the y-intercept, that is where your graph is touching the y-axis, represents the initial velocity of the object. Okay. Secondly, the x-intercept represents the velocity of the object being 0. It represents the time at which the object will pause. We know the object usually pauses where? At the maximum height. So when you see this in the graph, that's what you should expect, right? The gradient of the velocity versus time graph represents the acceleration. Of course, it makes sense because acceleration is constant, and the straight lines will represent a constant gradient there. And the area under the graph will represent the displacement. These are not the types of questions that we usually encounter, but anyway, we still need to know them. Right, here's an example of a velocity versus time graph. Based on the things that I've told you, you would know that this represents the y-intercept. The y-intercept is the point at which your line or your graph, this is your graph, is touching the y-axis, okay? This being the x-axis and that being the y-axis. So we know that the y-intercept represents the initial velocity, which means therefore that at this point, this 16 represents the initial velocity of the object. So this is an object which is launched with a velocity of 16 meters per second. What happens to the velocity, as you can see from the graph, the velocity decreases. When does that happen? That happens when you throw an object up. As it moves up, its velocity decreases. It will decrease until it reaches a value of 0. Obviously, at this point, at 1,63 is where we are going to be reaching the maximum height that the object will reach. Okay, so this means this is an object that reaches the maximum height after 1,63 seconds. Okay, but what happens after reaching the maximum height? The object does not stop. It only pauses after reaching the maximum height, and then it changes direction. Look on this side, the velocity is positive, and now the velocity is negative, which means the object has changed directions. After 1,63 seconds, the object now changes direction. It was going up and now it's going down. Hence, the velocity has a different sign compared to the previous motion. Right? And this is an object. This is an object that is likely going to return. If you look, you have two velocities that are of the same magnitude but different directions, because this one is negative, that one is positive. It means at this point, after 3,26 seconds, the object returns to the original height. That's why it has the same velocity, the same magnitude of velocity as at the top of our graph there. In a nutshell, this is just a velocity versus time graph. It's going to be a straight line. You should be able to read the graph if you're given the graph, and you should also be able to draw the graph if you are given the right information. Just know, if you know the initial velocity, that will be your y-intercept. And obviously, if you know the time for which it takes the object to reach the maximum height, that you'd know where your x-intercept would be. Okay, and then the gradient is it's always 9,8 meters per second squared, and then the area under the graph represents the displacement of the object. Those are the last 2 points, are not very common in our assessments. Right, now let's move to the position versus time graph. There is also the acceleration versus time graph, which I'm not going to talk about because there isn't much to talk about. It's just the horizontal line. Okay, now let us look at what happens in a position versus time graph. Number one is that the y-intercept represents the original position of the object. It represents where the object starts. If the object is starting from the ground, this is likely going to start from the origin of your graph, where your x-intercept, where your x-axis and the y-axis are in contact. Okay, then the x-intercept represents the point of reference. Okay, sometimes the question paper will tell you that the point of reference is the ground, or sometimes the point of reference is the top of the building. So most of the time the point of reference is the ground. All right, so the x-intercept represents where we consider the measurements from. We start measuring the height of the object from, or the position of the object from. That would be your point of reference. Thirdly, because this is a curve, this is not a straight line, this is a parabolic graph, we have a turning point. Now, the turning point of this graph, of the position versus time graph, represents the maximum height above the point of reference, the maximum height above the ground if the object was starting from the ground. Okay, and you have a turning point which represents this height. All right, now here's an example of a position versus time graph. Obviously, as you can see, our y-intercept is at the origin. Okay, which means this is the object. The initial point position is the same as the point of reference. Okay, the object is starting from the ground, assuming that this is the case. Then the object will go up and it will reach a maximum height of 122.5 meters, because that's the measurements there. That's why we see our turning point. There's the turning point of the graph. And then after 5 seconds, the object reaches the maximum height, and then it returns back to where it was launched from. And after 10 seconds, now the object reaches the same height from where it was launched. It was launched from the ground and it returns back to the ground. But this object, I chose this graph carefully because I wanted you to see some other possibilities with your assessments. This object does not stop after hitting the ground. It then bounces back up, and now it reaches a new maximum height, which is not going to go back to the original maximum height of 122.5 meters. It now reaches a new maximum height of 30.63 meters above the ground. Thus, hence you can see that we have a new turning point there. The object will definitely turn and then it will come back. Okay, so some of the questions they may ask you, how long did it take to reach the new height after bouncing? Or you'd have to check the time difference between this point and that point there, and you'd see that it's 2.5 seconds. Those are types of questions that you could expect. Just know how to draw the graph and how to read the graph when you are dealing with this particular topic, which is likely going to be question 3 of your question paper, or even question 4 if Newton's laws were divided into 2 questions, because that can also happen where your Newton's laws is divided into 2 questions, where one question is about Newton's first to third law, and then the second question is about Newton's law of universal gravitation. In that case, this would be question 4. Being a June paper, anything is possible. Okay, so make sure that you practice some of these things and make sure that you go to the exam ready. The first thing would be the definitions. The second thing would be the calculations using the equations of motion. The most important thing there is to know which equation to use at the time. And then the third thing would be the graphs. You need to know how to read the graph and also how to draw the graph. Okay, make sure you practice as much as possible. This has been Buto Academy, lessons that empower. I hope you feel empowered. We meet again in part 3 of these lessons, where we are going to be looking at momentum. Okay.